Um, Hi, welcome to my season 16 review video that I will be doing for instead of taking the test. Thank you, Mr. Held, for that. Let's hop right into it. He created the equation F equals K subset C parentheses Q1 Q2 over R squared. And that is very useful in all the practice problems we will do later on. With this next problem, we're going to talk about how the protons and electrons are separated by, let's say, 5.0 times 10 to the... Hi, welcome to my episode 1 review of season 16. In this video, we're talking about what occurs in season 16, episode 1, and how Mr. Held explains it, and how I will explain it to you too. He talks about how the tasers are used with police and other security agencies, how they are used, and they use physics, science of electro with the positive and the negative charges to just basically take over the central nervous system of the person that is being tased. Another thing is that electric charges are conserved. And one more thing is there's two types of charges. There's conductors and then there's insulators. Very important. For example, this right here is a neutral charge. And it's a neutral charge because it contains a positive, it contains a proton and an electron. And then those cancel each other out in a way to make it a neutral. So that's why it is a neutral charge. Important note, only negative charges move. Positive charges do not move. So only negative charges move when moving from a neutral to a neutral. Not necessarily a neutral to a neutral, just only negative charges move is what I'm trying to say. That was my season 1, or episode 1, season 16 review. Now on to the next episode. This is my season 16, episode 2 review of this unit, season 16. This video is all about ways of changing. There's the main concept of this video. One way to charge an item is charging by friction, by rubbing it together, you're charging something by driving your car because of the friction with the wheel and the road. So there's many ways of charging something with friction. There's a chart detailing what's stronger in a way. So if you had something like silk, would be at the bottom, and then another thing would be at the top. And if they're rubbing together, which one would get the electrons? Because which one has a stronger, I guess, resistance to the other one? This is that chart. One example problem is, example 1. Who would get the electrons from going to glass to steel? So who would? If you guessed glass would, you are correct, because glass is higher up than steel. So therefore, glass is the correct answer on that problem. That is my Season 6, Episode 2 review complete. Now we will move on to Episode 3 review. This next video is all about Kolob's Law, and there's even some math involved, which is just super fun. With that video you just watched, the important takeaway is that the plates are electrified until they are dropped. So these are the plates, they are dropped, and they're kind of like Zappo electrified. That's a big takeaway. If that wasn't there, the whole experiment wouldn't happen. This guy who did the experiment gave us the notion that the protons have a charge of positive 1.6 times 10 to the negative 19th, and the electrons have a negative 1.60 times 10 to the negative 19th, which is super big. It's a very small number, very useful in all of the equations we do. Is to be in your knowns tables of the practice problems that we'll do. Another thing this guy gives us is a very useful equation. He gives us F equals subscript K underscore C, or K subscript C, my bad. Parentheses Q1 times Q2 over R squared. Very useful. Be used in all the practice problems we do. Moving on to the practice problem, now we're going to have where protons and electrons are separated by a distance of 5.0 times 10 to the negative 10th. Now we're going to make a knowns table. We know Q1 equals 1.06 times 10 to the negative 19th, and we know Q2 equals 1.60 times 10 to the negative 19th. We know that because of over here we get those from the positive and negative electron. Those are the representation by Q. And we know R equals 5.0 times 10 to the negative 10th. We get that from there, the distance between the protons and electrons. That's what R is. We know K equals 9 times 10 to the 9th, and then from there on it's just plug and chug into the equation. I hope you guys can do that, and that will conclude our Episode 3 review of Season 16. Now we are on our Season 16, Episode 4 review, and let's hop right in. Sorry for that pause. I didn't know it was unavoidable. Didn't know how to fix it. Let's hop right in. This episode is all about electric fields. The field forces are all about how they don't create contact and they don't stop. So that's the field forces, and it just field forces with that. Yep. They also cannot be visualized with field lines. Therefore, they cannot be visualized with just field lines. Yeah. We're going to be using that equation, the F equals K times Q1 times Q2 over R squared. That's the distance. Q2 is the electric forces. K is the constant. F is the force. Keep in mind the density of the field charges and the lines. That is also very important. Like if you look at that 3 images, just make sure the density that'll come into play. What I want to get out of this video is for you to get out of this video is we want you to be able to determine pictures like these, the field forces, what force would be most dominating, if it's electric or if it's positive. On this photo, it would be positive, just because it's how it is. It's positive with the way the waves, and they're going to be overtaking the electric ones. This will wrap up my episode 4 review. It was quite short. I hope you enjoyed. Hope you learned something. Hope it helps you study or whatever you're using this video for. This is now my season 16 episode 5 review. In this video, it's all about the electric field math and how we do that, what equations we use, how we go about that. One equation that would be used is E equals Kc, which is a constant that we know, divided, and then Q divided by R squared, which is the distance squared. It's a constant distance. And then you have Q, which is representation of the charges. Our prox problem is going to be one with a distance of it's going to have a distance of 40 centimeters, and it's going to have an NC charge of 50. And in this problem, we're trying to find the magnitude. We're trying to find the magnitude of this problem. We're trying to find the magnitude, yeah. Okay, now we're going to have E equals K times Q over 4R squared. Because it's a 4, because it's an inverse squared, so it'll always be positive, so it's got a 4 there. No, I'm sorry, it's not 4R. It's not because of that. It's because you have a circle and you have 2R, and when you plug the 2 into the square, because you gotta square the whole thing, so it's 2R's radius, it becomes 4 because you're squaring the 2, and that equals 4. That's why you have a 4, and so now the R squared is just only over the R. Now you have to make it E. You have to make it E equals 4KQR squared, because this is going to become into a 1/4, and so then when you make that 1/4, the 4 goes on top and the 1 goes on the bottom, and that one you just don't have to represent. And that is how the math works, and there you're able to solve whatever you need to solve with that equation that you just got.
Hi, welcome to my Season 16, Episode 6 review video. And this video is all about lightning and how that correlates to electrons and the physics of it. One cool and interesting fact is that in your car, you're actually safer from lightning than you were if you went out, because the lightning basically hits it and then it dissolves around your car. So if you're ever in a lightning storm, stay in your car. In this picture right over here, this is something we call a Faraday cage. And in this video, you see the lightning, the shock coming, and in this Faraday cage, you're actually safe from it because the lightning goes around the Faraday cage and doesn't actually go to the person, it just dissipates around. And that's very useful and a very telling discovery. Another cool thing about the Faraday cage is that if you put a radio inside the Faraday cage, it will not work because of the wire. It won't work inside the Faraday cage, which is really cool. Another cool thing is actually a man in a helicopter. He was actually wearing a Faraday cage in order to not be shocked while he was working on the wire for the electric wire. So he would just work, he'd be at the work, and they'd be on the side of potential energy because he'd have a Faraday cage around him. Not like one you would see here, but like just a suit that acts as a Faraday cage. Next, he showed us a little object on a building that would actually pull the lightning from the clouds because of how negatively charged it is. So it would actually pull it, and so it would take the lightning from here and pull it. So it would. So now it wouldn't just, if it was good with heavy lightning, it wouldn't go to the ground, go right to that, and it would dissipate, which is pretty cool.